why do we use different modes? And the reason is, for example, if we just collect some data from our school and we look into it, for example, let's say we are talking about sports. So when we talk about sports, let's say we are talking about cricket, badminton, and table tennis. We may have multiple options. Let's just talk about these three at the moment. And if we have, like, we choose to draw like this: cricket, badminton, and tennis. Suppose we have 300 students at school and we collect this information that 75 are interested to play cricket and 200 are interested in playing badminton and 25 are interested to play table tennis. Now we may have different classifications or we may have more number of sports, and this is how we can represent. This is cricket, this is table tennis, that is badminton, and on y-axis I may have the number like 100 and 200, and for cricket this is 75, for table tennis that is 200, for badminton that is 25. That is one way of representing data. Second could be that we are representing as a pie chart and showing 75, 20, and 25 as angles. And how do we find these angles? 75 divided by total times 360. So 75 divided by total times 360, I'm getting 90 degrees. So 90 degrees would represent cricket. This is 90 degrees cricket, and for 200, 240 degrees would represent that, and for 25, 30 degrees. So if I just sketch a rough estimate, so that is tennis and that is badminton. Now these are different types. First we used bar graph, or we can use pie chart. But how did this data come to us? If we are showing this data to our principal, we may choose these two, and he or she will have a slight look at it and get the whole picture and would know, yes, maximum students are interested in playing table tennis and badminton. Maximum students are interested in playing badminton. That was 200. Or they may have a look at this and it is actually not showing the number, but they can interpret that more than half of the students are interested in playing badminton. But when it comes to our sports teacher, he or she may be interested in more detailed data. That is, for example, they may say that we have 300 students in senior school. They may ask how many are from grade 8, how many are from grade 9, how many are from grade 10. So we may have a split. Obviously, he may have these plans that we won't compete grade 8 with grade 10. We'll have matches between 8 and then between 9 and then between 10. So that depends which kind of data are we presenting and to whom. And how did we collect that data? That was tally. Have you ever heard this word before?
Yes.
So tally is like, I have this badminton, I have this cricket, I have this table tennis, and I go to one by one, I go to each student and I ask them, what are you interested in? And they said badminton. Next one, he said cricket. Next, again, he said badminton. Next, again, badminton, table tennis, badminton. And when we mark the fifth one, how do we do that? We just sit out. That's good. So that is easy to count. So principal might not be interested in this data. And if we are making a presentation, we'll be using either pie charts or bar charts. And sports teacher may be interested in maximum detail, that how many students from which class, which grade, and if we are talking about grade 8, we may have different sections as well, and so on. Now let's come to this. And there is one more thing. When we talk about tele, we know the actual data. When we talk about this bar chart, we don't know, maybe all of these students are from grade 10. So there's also limitation. We can say that actual data is lost. So we are having data collection that depends about what we are talking about. Then categorical data, we'll just categorize it. Qualitative, we are not interested in numbers. That is just qualitative. Let me show you these two. I say this is blue is the birth rate and this red shows the death rate. So what do you expect? The population to increase or decrease?
Increase.
Increase. And we never talked about the number. Are we talking about 10 million? Are we talking about 10,000? Is it so? So this is qualitative data. When we talk about numerical data or quantitative data, those are numbers. So we'll know we are talking about like 10 million and 2 million or 10,000 or 2,000. Now, discrete data is the exact data. If I ask you how many people live in house 3, so that would be exact number, that cannot be decimal number. Discrete data. Continuous data may be that data which is like decimal numbers, not whole number. For example, we ask someone how many days will it take to complete the task? They may answer 6.5 days. So that's continuous data. And primary data is the one which we collect. Secondary data is the processed data. We will process it. Like, for example, we are talking about mean, median, or mode. We are processing it. Primary is just the collection of data. Then we have the frequency table. Suppose we are talking about number of matches or number of goals. Let X be the number of goals, and 0 goals, 1 goal, 2 goals, and frequency. So we're talking about that we had 10 matches. How many matches were there which no goal was scored? So there were 7 such matches. So this is frequency table. Suppose there were 3 matches, we had 1 goal, and in 10 matches, we had 2 goals. So this is data for 20 different matches. 7 of those, no goal was scored. In 3 of those, 1 goal was scored. In 10 of those, 2 goals were scored. Grouped data. Okay. That would consist of different examples. For example, let me say there's a tree outside your house, and I ask you to collect leaves daily which fall. So we are collecting those leaves, and I ask you to write the length of those leaves. So it may be a very hectic task to note down the lengths. Let's say you note down that the leaf is 7 millimeters, then it is 7.3 millimeters, then it is 9 millimeters, and so on. You may have multiple lengths. So you classify them. You make those classes. We call it group data. How do you do that? You do it this way, that you say, I will count those leaves which measure from 0 to 5 millimeter, and then 5 to 10 millimeter, and then from 10 to 15 and 15 to 20. So it will be an easy task from 0 to 5. We can say we found 7 leaves. From 5 to 10, we found 13 leaves. From 10 to 15, we found 4 leaves. From 15 to 20, we found 1 leaf. Let's say this is 2. So for example, from 0 to 5, we have 7 leaves. But we are not sure, was that exactly 3.5 millimeter, 4 millimeter, or what? Now we have a broad idea, but we lost the actual data. We're just making these classes. So these are groups. If I talk about how many students are in your class,
My
school,
class. In my school, there is 200 students in my school.
200 in school, and roughly in one room, one class, the one you sit in, you have your chair there.
I have like 6 students.
Okay. So if we have six students, let's say in one grade, roughly, we have 30 students. And if I'm talking about their heights, so let's say one of the student height is 5 feet, the other is 5 feet and 2 inches. Let's say one is 4 feet and 11 inches. And let's say there's one with 6 feet. We may have different values. If we write all these heights in order, that will be a very hectic task. But what we can do is, if we say count how many are from 4 to 5 feet, and then from 5 to 6 feet. So we may have two different classes, or we may split them depending on the data. That split them from 4 to 4.5, and then from 4.5 to 5, and then 5 to 5.5, and then from 5.5 to 6. And how do we write them exactly? This would be 4 is less than equal to x, which is less than 4.5. So 4.5 actually falls in second group, is less than equal to x is less than 5. Where do we write if someone is 4.5? We write it in the second group. So 5 less than equal to x is less than 5.5. So this is how we make groups depending on our need and how detailed data is required. So this is about the groups. Now stem and leaf, this is one interesting mode of collecting data and displaying data. We do not lose exact data in this way. Two-way table, pictogram. Pictogram is very interesting. Just like the bar graphs, then bar, pie chart, and line graph. Let's study them in detail. A recap. Have you studied this before? Ways
Yes.
of organizing this. Very good. So scores and frequency, we have that frequency table of ungrouped data. These are grouped and ungrouped data. When you have like discrete values, they are ungrouped. And when we talk about like from 0 to 9, just like this one, 0 to 9, 10 to 11, 20 to 19, 30 to 30, and so on. So these are groups. And this right here is pictogram. The key shows that one circle means four medals. So I know that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 4 times is 44, plus half of the circle should be 2. So these are 46 medals. Getting it? So this is pictogram. And again, it depends. If we are displaying this data to principal, she may be interested to see, okay, United States won the most medals and Germany won least medals. And when we just look at this graph, and let me hide this x-axis. So it says pictogram used mostly for visual appeal effects, obviously. And you can just by looking at it, you know that which state is winning the most medals. And when obviously someone who has to do the analysis, like sport cricket critics, they may need the exact numbers as well. They may also ask you that in which game are they winning these medals. So this is pictogram. Pie chart represented in circular form. So gold medals, context. If we don't like, if we just look at these colors, I can see this orange having the maximum angle, having the maximum coverage. And this is the key. Europe won the most medals. And least is this light green color, which is South Africa in this case. Now, this is the line graph. And lines would depend on the type of data that we draw them straight lines using ruler, or we will draw them freehand. For example, I have these dots and we draw a freehand curve or we draw straight lines. It would be clear in the question. Okay, collecting and classifying data. Obviously, if if a company who makes toothpaste, they asked me to collect data. So I'll go door to door, person to person, and ask about it. Obviously, we have different modes of measuring data today, that is online, filling out a form, giving a feedback form, and so on. So even then, individual person will have to answer that which toothpaste are they using, why do they like it? The reason may be the price, the reason may be quantity, the reason may be the aroma they like, or the performance, or the feel fresh. And there may be a survey for like ice cream, which flavors do you like. So they basically, when you get a survey that in region X, most people they like vanilla and least people like chocolate. So where is the company going to invest the most?
Vanilla.
In vanilla. So that's why they need this data. And along with that, some people actually own more than one company. Let's say both flavors are their own, both type of toothpaste are their own, but they know what people like. So they can either invest in that one piece, or they may improve their other products as well. So collecting and classifying data. Data is set of facts, numbers, or other information, statistics involved in process of collecting data and using it to try and answer a question. The flow diagram shows four main steps. So first we identify problem, and then we collect data. What do we need to know? Then organize and display data. Now, I saw that example in an hospital. It was horizontally displayed, this red bar, and then there was a green bar. And then it kept on changing, green, and then again red. This was displayed in an hospital. Okay, now there were written numbers and years. Let me say this is 1990 and this is 2000. So this is a compilation of 10 years. This was 1990 for 10 years and 2000 for the next 10 years. And green showed the birth rate, red displayed the death rate. And how do we relate this? This would be if ever in life you appear for like IELTS or analytical exams, they do ask you that what would have happened to change the graph, why the red bar is decreasing, why the green bar is increasing. So the simple answer to this was medical facilities improved in that decade. So they're actually controlling the death rate. Medical facilities better, and someone also answered that awareness. Some may not need to visit the hospital. Awareness was increased and people are not getting sick. And the birth rate, if the birth rate is increasing, or let's say the life expectancy is increasing, displayed by red and green. And in both of these, when we go closer, only then we can see what is the count. It may be in thousands, it may be in hundreds. Now, if it is displayed by that hospital, we are maybe talking that region only. So this graph, this data could be implemented on similar regions. And then we analyze and interpret the data. Can you summarize the data? What trends are there in the data? So if this trend continues, if we are like now we are in 2024, and if this trend continues, I may expect a very short red bar and a long green bar, because the red bar is reducing in size if we follow the trend as displayed in these lines. If I see this orange line is always at the top and mostly increasing. If I see this purple line, that is decreasing. Now, there was another thing. There were two graphs, population and number of fish. So population was increasing and number of fish was decreasing. That showed that number of people are increasing and they like to eat fish. That is why fishing areas and fishing timings are there and breeding season is there. That is why there is a ban that you cannot fish in these months, just to control and have sustainability. Does the data raise any new questions? Okay, it may raise a question in this case that we are happy that that death rate is decreasing, medical facilities are improving, awareness campaigns are improving, but why is the birth rate constantly going up? It may raise this new question. So either the mode of data is different, or either we need to put in some campaigns in that area too. So are there any restrictions on drawing conclusions from the given data? That depends. Let's try a few questions and we'll see. Okay, copy this table onto your notebook. Categorical data is hair color, numerical data, number of brothers and sisters. Okay, add 5 examples of categorical data. Now, few of these examples, obviously, I would have to create hypothetical situations. Some of these exercises are exactly designed to give student an hand-on experience. What our teachers used to do was to send us into a particular section and they asked us to collect the data. Those were mostly about the heights and the fruits and the flavors students would like to eat. And let's consider this hair color. So if I talk about my family, I think all of them have black hairs. So if I just have an experience of some friends, yes, they have a lighter shade of color. So if I can classify like black or brownish and black and brown and so on, and then number of brothers and sisters. So this is just a rough data which we could compile. And when we reach to school the next day, how much we have? We'll have 6 such tables in your class. And we can combine them and answer these other questions. Add 5 examples of categorical data and 5 examples of numerical data that could be collected. So if he said this, let me think of one. Okay. Let's say I'm talking about my family and I'm asking them what type of dressing do you usually do? Traditional or Western? And I may have few answers. I'm asking my brother, then I'm asking my father, then I'm asking my sister, then I'm asking my uncle, and so on. Getting the point? So I may have a data. Then second, then third, then fourth. And when we collect that data, let's say we got one such answer as this 1, 2, 3, 4, 5, 6, 7. What do you think? What's happening in the second table?
Well, the Western is increasing.
The Western is increasing.
No.
We are talking about a particular family.
Mhm.
All of them prefer Western. One way. And we can also tell that there are 7 family members, right?
Mhm.
So we can interpret few things from the given data and we cannot interpret maybe all of them are under 30 years of age. When I talk about my father, he is very happy when his like dressing shirts and trousers are a bit loose. He's old. He feels comfortable sitting, standing, moving around, and so on. And maybe I live in that area where most people prefer traditional and so on. So state whether the following data would be discrete or continuous. So when we are talking about these two options, it has to be discrete because we are talking about number of people. If I ask you, what do you prefer? That would be a discrete, solid one answer. I cannot say 0.6 of Balam considers this and 0.4 of Balam considers this. I can't say that. So that has to be a discrete data. Now, I have 3 rooms in my house. One is actually painted white, the other is painted pink, and the third is painted white and black. And when I talk about my uncle, he has a house all 4 rooms are painted white. So we may have same color, we may have different color, we may have different shades. This data could be continuous data. This is not discrete. It is not necessary that you'll have white room. You may have 3 walls white and one is black.
So it doesn't have to be
So
decimal either.
it doesn't have to be. If I'm talking about that one room, I can say 0.7% or 75% of it is white and 25% of it is black.
Okay.
So, okay, state whether the following data would be discrete or continuous. Mass of each animal in a herd.
Continuous.
Very good. Number of animals,
Discrete.
discrete. Continuous, discrete. Time taken to travel to school.
Continuous.
Volume of water evaporating from dam.
Continuous.
Very good. Number of correct answers in a spelling test.
Discrete.
Discrete. Distance people travel to work.
Continuous.
Continuous. Foot length of each student in class.
Continuous.
Continuous. Shoe size.
Continuous.
Okay, we may have different experiences. I'm highlighting this question.
Okay.
In Pakistan, we have these shoe sizes 6, 7, 8, 9, 10.
So
And at most, sorry,
so that would be discrete because there's no like decimals in it. It's
yeah, in that case. And I've like seen someone do ask that, for example, my shoe size is 42 against 8. So they do ask, they have these standards. Usually, but we don't get into this. The salesmen are very experienced, and we also can see in the display area that this is my size. So they are like, one is the British standard, one is the international standard, and so on. And then I have also seen that era when we had 6.57, 7.5, and so on. So when it is not a whole number, yes, you're right, it could be continuous. Head circumference of newborn babies,
continuous.
continuous. Number of children per family,
Discrete.
discrete. Number of TV programs watched in last month,
Discrete.
discrete. Number of cars passing a zebra crossing per hour,
Discrete.
discrete. So for each of the following questions, state one method you could use to collect data. Whether the source, okay, let's discuss the C part. How many times will you get a 6 if you throw a dice 100 times? So one method.
You could
Let me
do
give you options. We had a pie chart. We discussed a tally. We discussed a group data. We discussed frequency table.
maybe a pie chart.
Okay, if we are talking about the pie chart, you are throwing this dice 100 times. Now consider this is a dice. I'm shaking it and throwing it. What do I get? 1, 2, 3, 4, 5, 6. One method you could use to collect this data. How are you collecting this data? How would you remember without writing? How are you actually collecting this data? You'll make the pie chart when you have the data. How many times did you get a 3? How many times did you get a 4?
Then we could do a frequency table.
Yes, we can do that. Frequency table, or we will have to pass through a tally because we are talking about 100 different attempts. So it would be a tally in this case. Whether the source of data is primary or secondary,
Primary.
primary. Whether the data is categorical or numerical.
Numerical.
If the data is numerical, state whether it is discrete or continuous.
Discrete.
Yes, in this case, it is discrete. Now, organizing data. Once tally is there, this is the tally. Now we can do anything. Either we want a bar chart, vertical bars, horizontal bars, or we need a pie chart, or we want to display it as stem and leaf, or we want to display it as group data. That depends on our use. What are we collecting this data for? So we have this tally. These are cars, white, red, black, blue, silver, green, passing one of the junction, and we are collecting the data. Different example. I'm actually looking for something interesting. Okay, we just discussed such question. Let's do this. Balsam threw dice 50 times. These are her scores. Draw a tally table to organize her data. So these are 50 different outputs. And if we are throwing a die, we are having 1, 2, 3, 4, 5, 6 different outputs. How do you suggest we calculate this data?
With tallies, basically, just count them. How many four is there, or how many ones are there that she got?
Yeah, sure. That's the right way. So if I look at this one, now I have that uh, accessibility that I can just cross it out. That works for me best. What I do is I cross out all the ones and I'm counting them. 3, 4, 5, 6, 7, 8. So these are 1, 2, 3, 4, 5, 6, 7, 8. In case if I've missed any, that would be uncrossed. And I can see it at the end. So I'm done with one. Let me count these twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now 3, 1, 2, 3, 4, 5, 6, 7. I'm not writing these numbers exactly because I have to see if I don't miss any. Then fours. 1, 2, 3, 4, 5, 6, 7, 8. Fives. 1, 2, 3, 4, 5, 6, 7, 8. Now 6. 1, 2, 3, 4, 5, 6, 7. Now we have this data that is 8, 12, 7, 8, 8, 7. Now I'm going to total them all and see if it is 50. 8, 12, 7, 8, 8, and 7. I'm getting a 50. So that means I didn't miss any. So this is our tally. Now we can use this data for different purposes. Do a quick survey among your class to find out how many hours each person usually spends doing his or her homework each day. And draw your own tally table to record and organize your data. So this would be such, we have different students. So let's say A, B, C, D, E, and F, 6 students. And we can ask that how many hours are they taking. Result threw 2 dice together 250 times. I suppose she must have a lot of time and recorded the score he got using a tally table. Look at the tally table and answer the questions about it. So this is the table and what questions are there? Which score occurred most often?
7.
Which two scores occurred least often?
12 and 2.
12 and 2. Why do you think Fazil left out the score of 1? If you read the statement, you will get the answer. Starting right there. Need help?
Fizzle.
Okay. If you are throwing two dice and writing the score he got, two dice together, 250 times the recorded score he got, usually a table tally looks and the answer about it. He's adding up those scores. How is he getting 12? He's adding those two scores and writing it. And if you are throwing two dice, you can never get an output of 1. The least score on first die could be 1, second die could be 1, and the total would be 2.
Oh, so it's not 2, this, like, he rolled 2, like, 7
He will
times.
never get 1. Yeah, no, that's a 2 because he threw ones and ones a 7 time.
Oh, okay.
He's throwing two dice. Can he get a total of 1?
No, you can't, because when you add them together, you can never equal 1.
So that's why he is not writing that score. D part. Why do you think he scored 6, even, and 8 so many times? 6, 7, and 8 so many times. Okay. Now that's okay. Why do you think he scored 6, 7, and 8 so many times? We may have different opinion, and both of us may be correct. Sometimes in the marking scheme, it is written that up to the checker's judgment. So let's discuss why is he getting 6, 7, and 8 so many times.
If he's rolling it in a specific way, then it could also lead the number to roll onto 6, 7, or 8 many times.
Okay, if we are like having a fair throw, he won't be looking at the die. That would be in a box.
Mhm.
Okay, what is the possibility to get a 2 other than 1 plus 1?
I don't think there's any else.
And if we talk about 3, that could be 1 plus 2 or 2 plus 1. And let's consider that 1. I'm erasing the other because there are 2 and 1. If we talk about 4, it could be 3 plus 1. It could be 2 plus 2. If we talk about 5, it could be 1 plus 4 or 2 plus 3. If we talk about 6, that is 1, 4. That is 1, 5, 2, 4, 3, 3. So you see the chance of getting 3 is increasing, getting 6 is increasing. We have only this combination for 2. We have two different combinations for 4, two different combinations for 5. But when we talk about 6, our number of chances are increasing. Because we may get 1, 5, 2, 4, and 3. So total chances of 6 are increasing as compared to this 3, which is only possible when we get 1 and 2. We are also getting this 1 in 6. We are also getting this 2 in 6, but we are not getting 5 in 3. We are not getting 4 in 3. We are not getting 3 itself in 3. So why do you think he scored 6, 7, and 8 so many times?
Because
Because the chance to get a total of 6, 7, 8 is more. Let's try for this 8. This could be 2 plus 6, 3 plus 5, 4 plus 4, and so on. Clear?
Mhm.
Frequency tables. A frequency table shows the total tally marks. Some frequency tables include tallies. Usually in exam, we will get very less of this tally questions. These are just to build up the base, build up the concept. Grouping data in class intervals. Now we have different type of class intervals. At start, we'll be studying the basics. If you see from 40 to 44, these are 4 numbers. 44 minus 40, then 49 minus 45 is again 4. So the class width is constant throughout. If these numbers are inclusive, these are 5 numbers, then 5 again, then 5 again. We will face that data which will be having different classes, different class width. So what does the question has to say? Grouping data, we have the frequency, we have the points scored. Like we have 40 of those people. If we write all the marks, this will be a very long list. So we've categorized them that anyone who scored 40 to 44, we count them. 45 to 49, we count them. If we are having an assembly and principal is asking the students to raise their hand if they scored more than 90 in an exam. So more than 90, you see like 9 hands. But you cannot tell they were at 91, 92, 93, 94, what were there. Principal would never ask who scored 100. Then the second question, who scored 90. Then the second question, who scored 99, who scored 98. She would say, how many of you got between 80 and 90? How many of you got between 70 and 80? Getting a fair idea what percentage of students lie in which category, in which class. 4.3. Sheldon did a survey to find out how many coins the students in his class had on them in their pocket purses. These are his results. Copy the frequency table and use it to organize Sheldon's data. So zeros. 1, 2, 3, 4, 5, 6. These ones, this is 1, 2 only. Twos. 1, 2, 3, 4, 5, 6. Threes. 1, 2, 3, 4. The fours. Not there. 1, 2, 3, 4. Fives. 1, 2. Sixes. 1, 2, 3, 4. Sevens. 1. Eights. Only 1. A quick total before we proceed so we don't get a wrong answer. 6 plus 2 plus 6 plus 4 plus 4 plus 2 plus 4 plus 1 plus 1. That's a total 30. So this is 3 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the question is, what is the highest number of coin that any person had on them?
It was 2 or 0.
Highest number of coins.
Oh, okay.
I think you confused it with the frequency,
Yeah.
most frequent. That's it. How many people had only one coin on them?
2.
Two. Okay, before we proceed, what is the mod of this data?
4.
What is the maximum frequency you see in this table?
6.
6. So the mod is not 4. It could be 0 and 2. 0 appears 6 times, 2 appears 6 times. So mod is 0 and 2. Normally, when we have two different, it has to be unique. So we'll write there's no mod, but 0 and 2 appears maximum number of times. This chapter is actually, this makes you fall asleep. This topic is boring. That's why I'm trying to like create scenarios from real life. Penny works as a waitress in a fast food restaurant. There are amounts in dollars spent by 25 customers during her shift. Now, this is going to be a little hectic. Copy and complete the group frequency table to organize the data. When it says from 0 to 9, 0 to 9.99. So I am having 10 in my head and I'm writing every value which is less than 10. So 0 to 9.99. 1, 2, 3, 4, 5, 6, 7, 10 to 19. So I'm having these two digits in my mind. First in 1 and last is 2. And I'm not going to count 2. So 1, 2, 3, 4. You see, this first digit is 2. I just kept it. 5, 6, 7, 8, 9. Now from 20 to 29, I'm looking at 2 and I'm ignoring those which are starting with 3 because 3 would make it 30. 1, 2, 3, 4, 5. From 30 to 39. So I'm ignoring this digit 4. 1, 2 only. 2 to 4 to 49. 1, that's 1. 50, this is the only one left. How many people spent less than $20?
16.
Very good. How many people spent more than 50?
1.
1. What is the most common amount that people spend during Penny's shift?
10
Three.
to
Very good, very good.
10.
Because now this was the question about the most frequent. Now, can you actually tell how many people were there who spent $12 if I give you this amount and frequency table?
No.
If I give this table, no. And if I ask and give you everything and I say how many people spent $12, so you can exactly tell me that there was no one because there's no amount written as 12.00. So this depends. This depends. If I am like um, drawing bars, even if you answered this question was easy, what is the most common amount? But you had to give it a glance, like 1 to 2 seconds, and see which one is the highest number. And if this data is displayed in a bar chart, suppose I draw the bars, this is from like 0 to 9.99. So let's say this is the height for 7. This is the height for 9. This is the height for 5, height for 2, height for 1, and height for 1. Now, in this case, you won't have to read or consider. You are very clear that this is the highest. Second class is the highest. So this depends who are you going to present the data. Have you ever heard about the elevator's pitch? You know what elevator is?
Yeah.
Okay. Elevator pitch is something. This is a real life example, and I'm forgetting their names. Suppose there's a person who's very influential, or say he's a billionaire, or say he owns a company which you dream of. So I'm actually trying to meet someone. And where did I meet them? I'm trying for last 2 months and I'm unable to meet them. And where do I meet them? In the elevator. We both entered the elevator. Now, what time do I have to present my idea? Let's say he owns a automobile company and I have an idea about the shape of the car. So I just have a few seconds or maybe 30 seconds before he reaches his floor. That is called an elevator pitch. I may have a detailed presentation which would take 25 minutes, or if more details are required, that could take 6 hours. But elevator pitch is that time which I just have to show him or say a few words that he gets interested. So sports data, when two of the students are talking to each other, they may consider let's go for a tally, let's go for a count. Okay, let's go for a hand raise. They may agree that let's get the a list of names printed from the office because they do have the record of attendance and so on. So you two may discuss that let's get these data counted by this number. What if the sports teacher asks who is interested in badminton? How will we tell them? We can always tell them that there were 75, but who were they? So that depends where you have to present that data. So that is the elevator pitch. And depending on the scenario, we decide what presentation would suit the most. The best example of this would be consider a system like where we are talking about to the ministers, politicians. So those are the people who do not have the technical knowledge. Let's say we are talking about the road designs of a city. So they don't have the construction knowledge, they don't have the transportation knowledge, but you are the one who have to convince them. So this presentation will not include that the depth of the road will be 8 inches. This is the aggregate which we will use. And other place, the data would be presenting that this will lessen the traveling time by 2 hours. This will lessen the load of traffic on highway number 5 and so on. Stem and leaf. This is interesting. Let me get a big example. Okay, this one is better. Now, if you just look at this worked example, before we go into this raw data, if I just make you look at the stem and leaf below it, this shows 1, 2, 3, 4, 5. On the other hand, this shows 8, 9, 7, 3, 5, 8, 9, 0, 5, and so on. Now, this is rough. We will uh, polish this data in next minutes. Now, this here says 1/7. The key says 1/7 means a 17. So now I can read that this is 18, this is 19, this is 17. I can read this is 55, this is 48, this is 39. Getting it? Now looking at this stem and leaf diagram without going into questions and statements, I can say that most people are between 30 and 39. Or I can say people are between 30s. if I only give you this data, now stem and leaf is that data which gives you the factual values. Original data is not lost. Whereas in this question, original data was lost. When we give this table, now we don't know this was $4.25. It was $3.9. What was that? But we know that between 0 to 9, there were 7 people. In stem and leaf diagram, original data is preserved. Now, there's one thing which needs to be done in this data. We'll be doing it later. That is always keep that in order. If I try to draw it here, this is 1, 2, 3, 4, 5. Keeping that in order, starting from 7, then 8, then 9. This is organized. And when we talk about this 2, this is 0, 3, 0, 3, 5, 5, 8, 9. You see, now I can clearly tell that it lies between 20 and 29. Other than that, I would have to have a closer look. Okay, smallest value is 0 and the largest is 9. So one requirement of stem and leaf is keep them in order. Second requirement is write all the numbers below each other. So writing below each other, we can see that 0, this is the maximum class. And now once I write them in order, I can actually see these two fives occurring with each other, 25 and 25. So it would be very easy to identify the model number as well. So this is stem and leaf. Okay. Brand X leaf, stem, and brand Y leaf. Key is given for brand X, 8/2 means 28. Now we always read it as it is written. A on left, 2 on right. So this is the 2 on right, this is the 8 on left. So 8/2 means 28. So if this is 28, what is this?
32.
Very good. And what is this?
2. 20.
Careful.
2.
2. And what is this?
17.
17. So that's how you read the key. And on right hand side, that's easy. 4/2. This is 4/2 means 42 hours. So once we understand that key, we definitely need it when we have to give a discrete answer. Other than that, overall, we can clearly see that which class has the maximum values. If I'm talking about brand X leaf, so we know that from 2, 7, 8, 4, 9, that's not the model class. So it is in 20s. And model number is exactly the one which occurs the most. I can see these 8 2 times and these 7 2 times. So there's not a mod in this case. You read the data of band X from right to left and stem right tens and from left to right for brand Y. Now the mass of some grade 10 students was measured and recorded to the nearest kilogram. These are the results. Construct a stem and leaf diagram. Okay, now before doing so, let's see what is the least mass in question 1. And out of these masses, which is the least mass?
45.
45. So we are not writing it. This is in our mind. 45 is the least mass. And what is the greatest mass?
67. 68.
60,
8.
68. Now, we know that the least value is 45, the greatest value is 68. Will we ever discuss like 10 kgs, 25 kgs, 30 kgs? So looking at this data, we now have the idea that we can have our stem from 4 to 5 to 6. If I just look at this first number, I'm writing this 5 and I'm giving this key that 4/5 means 45 kgs. Now, when I'm done with the first number 45, I'm looking at 56. So I can write a 6 here. Third number is 55. I can write a 5 here. 68. There goes the 8. 53. There goes this 3. I'm speeding up a little. I need to complete this question. Okay. Is that fine? 55, 48, 49, 53, 54, 56, 59, 60, 63, 67, 49, 55, 55 is in the other line. This is 55. 56 is there. 58 is there, and last one is 60. Data complete. I'm coming to the writing space. Copying this down. 4, 5, 6. Quickly 5, 8, 9, 9. 6, 5, 3, 5, 3, 4, 6, 9, 5, 6. And that is 8. And in the last line, I have 8, 0, 3, 7, 0. Now there were two conditions. Write the numbers exactly below each other and in order. So if I have my stem 4, 5, and 6, I'm looking at 4 only. I can see 5, 8, 9, 9. Luckily, they are already in order. We do not need commas to separate them. Now I'm looking at 5. So the lowest number is 3, which appears 2 times. Then I have 4. Then I have 5, 5, and 5. So that's 5. That's 5. And that's 5. So 6 is 1, 2, 3 times. 6, 6, and 6. There's no 7. There's 1, 8. There's 1, 9 as well. When we look at the last line, that is 0, 0, 3, 0, 0, 3, 7, 8. Now you can see the least value is 45, the highest value is 48, and everything is in order. So that is stem. Those are the leaves. Now, if I ask you the median number, you will be able to answer because you know the middle. Total of this was, if it's given in the question. If no, we can always count them. The mass of some grade, okay, total is not given. So we can count them. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these are 20 students. If I'm talking about the median, that is the middle, that is 10th and 11th student. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10th. This is the 11th student. And that is 55 plus 56 by 2. So median mass is 55.5. So this was stem and leaf. Let's see what the question has to say. Construct the stem and leaf diagram to display the data. Done. Any confusion in drawing stem and leaf?
No.
Question 2. Draw a back-to-back stem and leaf. So what would it be? We will decide that. Either we write 1. It is never suggested to have a double digit on the leaves. That is always a single digit. So we'll decide double digit for our stem and leaves on the other side. So if I just look at this data, why is it stuck? It crashed. Okay. So if we just look at the table data, we'll decide the least number and the greatest number coming right through. Okay. Draw a back-to-back stem and leaf diagram to display the data. So we will have to decide. For example, again, I'm looking at the least and maximum numbers, but in this case, I'll have to look into both. All are 3 digits. So least possible could be 100. But if it is not there, let's see, 132, 115. So I'm getting a least data of 115 in this and a maximum of 200. Maximum of 200. Now for the second one, that is 200, 201. So I think 115 to that is actually doing for us. So I'm starting with 10, writing 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now, I think you would have followed what we are going to write on the right hand side. 175. So I'm writing against 17 and I'm writing 5 on the other side. So I'll read it as 175. If I look at 132, I'm looking at 13 and writing 2 on the other side.
Do we
I'm
have
reading as
10?
not necessary. If we don't have any value in 1, 0, you can ignore that. Just like this, if I'm looking at 201, this will deal from like 200 to 299. 200 to 209. So now we can give them the key that 1, 3/2 means 132. And we write all this data. I will share one question from stem and leaf and maximum 2 questions from this topic so that you're able to complete it before the next class. Okay. So we discussed few modes of displaying data, but we solved it for like only group and stem and leaf in this class. And inshallah, we'll look at the other modes in the next. We discussed few of the terms and we continued through the exercise and practiced 1 to 2 questions. For tele, mostly, and discussing stem and leaf diagram. Okay, let's try this question. The stem and leaf diagram shows the picture, shows the pulse rate of a group of people measured before and after exercising on a treadmill. So pulse rate before exercise on the left and after exercise on the right. And what does this key shows us when we talk about before exercise? Okay, this is not necessary normally because the book is making us understand. Normally, it is not necessary that only the first one would be given as the key. It could be any number, so we'll have to look for it. So that says 2/6. So I have to find 2 on left hand side and I have to find 6 on right hand side. And so this is the only option. 2/6 means 62 beats per minute. So that's 62. And after exercise, 8/7 means 87. So we know how to read it, what the value means. So
Oh,
how many people had a resting pulse rate before exercise in the range of 60 to 70? So we already know we are talking about this 60 to 70. So I'm looking at 6 and 7 only.
11 people?
Very good. 11 people. No. Why no? Because this is 73. This is 74. This is 71. This is 72. And we have to stay between 60 and 70.
Mm, okay.
So it would be 1, 2, 3, 4, 5, 6, 7. B part says what was the highest pulse rate measured before exercise? So before exercise, what is the largest number?
101?
101. C part says that person also had the highest pulse rate after exercise. What was it?
109? 109?
I can see something else.
Oh, 142.
142. What does this stem and leaf diagram tell you about pulse rate and exercise? Now, this is the observation. What do you observe? Generally, what happens before and after exercise to the pulse rate?
Well, their pulse rate increases.
Pulse rate.
No longer in the 60s and 70s zone. It goes up to like the 80s.
That's right. No more longer in 60s, 70s. Okay, two-way tables. This stem and leaf diagram was also two-way. A two-way table shows the frequency of certain results for two or more set of data. Here is a two-way table showing how many men and women drivers were wearing seat belts when they passed a checkpoint. So wearing seat belt, 10 men were wearing seat belt and 4 were not. 6 women were wearing and 3 were not. Two-way data. It is about men and women and wearing or not wearing. The heading of the top of the table gives you information about wearing seatbelt or not. Downside gives you the information about the gender. So you can use the table to find out how many men were wearing table and belts. So basically, again, we'll categorize these as analysis graphs or analysis tables. Let's get started with the question directly. It's not that hard. The teacher did a survey to see how many students in her class were left-handed. She drew up this two-way table to show the results. So we're talking about girls and boys and left-handed and right-handed, and the data is in front of us. How many left-handed girls are there in the class?
9.
How many of the girls are right-handed?
33.
Are the boys mostly left-handed or mostly right-handed?
Right-handed.
No, right-handed. How many students are in the class?
90?
90 students. How do you feel it when you calculate 90 students in one class against 6 of yours?
Too many people, to be
Can
honest.
you imagine the level of understanding like student to teacher ratio?
There'd probably
Th-
have to be like 3 teachers.
That would happen in universities. Large benches, and it does work out when people actually know where they are and how they have to behave. Do a quick survey in your own class to find out whether girls and boys are left or right-handed. So what we'll do, we'll use the same table and we'll just ask out the questions and fill in the table. So I can say this is one of the way to record these statistics, to display the data. Question 3. Seema asked her friends whether they liked algebra or geometry best. Here are the responses. So names algebra and geometry. And where's the question? Okay. Draw a two-way table using these responses. Write a sentence to summarize what you learn from your table. Okay. Hmm. I am thinking of considering these two only. Where did it go? Okay. I'm ignoring these last three, so I don't have to move up and down again and again, and we can talk about this data. So when we have to draw a two-way table, as discussed earlier, we should have four different options, or we may have more than four options, and we may say one is horizontal and the other is vertical. Horizontal headings and vertical headings. So left-handed and right-handed. So we have algebra and geometry. If I just write these, may I have these options? Like, what were the wordings? Friends, whether they liked. So I was about to write preferred.
Likes algebra, doesn't like algebra.
Yeah, like or not like. So we can always count how many like algebra. So let's do it. 1, 2, 3, 4, 5. So 5 like algebra. And 1, 2, 3, 4. 4 like geometry. And how many would not like are these? That is one way. Other way could be we can change this into boys and girls. Boys and girls. Now I would be very confused to guess which one is a boy and which one is a girl, because we do have names for both the genders. At least in my experience, like Miss Bashi was my teacher at school, female teacher, and we have a cricket player who's male and named Misbah. And there are other names. So let's make a guess. What do you think Sheldon is? Male, female?
Boy.
Sorry, I didn't. That's a boy. Leonard is a boy. Raj is a boy. And what's Penny?
Girl.
Penny's a girl. Howard?
Boy.
Boy. Zara is a girl. Zuhair is a boy. Ahmed is a boy. And Jenny, I suppose she's a girl. So if we work out these, so how many boys they like algebra? So boy 1, boy 2,
Boy.
boy 3, boy 4. So 4 boys like algebra. How many boys like geometry? That's 1, that's 2. How many girls like algebra? Boy, boy, boy,
One. Only
oh, only Jenny. And geometry. Penny, Zara, 2. So just looking at this table, ignoring these three, if we just look at this table, we can say we can make different comparisons. Like most of the boys they prefer algebra over geometry, and most of the girls they prefer geometry over algebra. Any confusion?
So the four is basically they like algebra, and the one on the bottom is they don't like it. So which part shows that they like it and which part shows that they don't like it for the boy and the girl?
So if we discuss this thing, how many boys like algebra is 4, and definitely those who are not in this box lie somewhere else. So 2 boys do not like algebra.
Okay, okay.
How many do How many girls do not like algebra?
2.
2. How many girls like algebra?
1.
That is 1. Now, draw two-way table using the responses done. Second says, write a sentence to summarize what you can learn from the table. So we can write all these 4 numbers in our table. 4 boys are taking algebra, whereas 2 boys take geometry. 1 girl likes algebra. The other 2 prefer geometry. Or we can also say most of the students prefer algebra. There are 5 in algebra and 4 in geometry, or more than 50% would prefer algebra. So two-way tables in everyday life. So these are simple ones. I think we've always seen these tables, but never named them as two-way. For example, a region, world, Africa, North America, Latin America, Asia, Europe, Oceania. And on the other hand, we have population in 2008, then 2025, which is not here yet, and 2050. So we are projecting it based on some data. So we see in these two tables, I see a slight increase in Oceania, whereas a great increase in the world population overall. And do we get a decrease as well
In any of the results? In Europe,
in Europe?
it goes from.
So the prediction says it decreases slightly in the next like 40 years from 2008 onwards. And on the other hand, so this is what we can like comment on the given data. A part says what was the total population of the world in 2018. So we just have to read it off the table. By how much is the population of the world expected? Okay, just remembered one thing. Do you know how to write these numbers in standard form? I'll write the first one. It says what was the total population of the world in 2008. If I just look at this number, this is 6705. And then I have 6 zeros, 1, 2, 3, 4, 5, 6. So if I just convert it into standard form, these are the things which we have to see. We put a decimal after the first digit always, then 705. Now what I can do is I'll count. See if I put a decimal right here and I'm counting 9 digits after decimal. So I'll write into 10 raised to the power 9. So I don't have to write all the zeros. That is standard form. B part. By how many is the population of world expected to grow by 2025? So it is expected to grow by 8,000 million people.
Is it saying we subtract the both numbers together or just we write 8 million?
Okay, we can answer that by how much is it expected to grow. Either we write 8,000 million or either we write there will be an increase of these much people.
Okay.
And definitely in other words too, if I need to find the percentage, I can say it increases by this much percent. Not going into that, I'm waiting for the topic to be here. So we study all of that like profit, gain, cost price, loss price. C part says, okay, that's right there. What percent of the world's population lived in Asia in 2008? So if we look at Asia, I'm looking at this digit 4052 because there are all 6 zeros. And when I look at the world's population, there are again 6 zeros. So we can use only these first 4 digits to find our answer. 4052 by 6705 times 100. Does it make sense if we ignore the 6 zeros in both of them?
Yes. It's like simplifying them basically.
Yes. I'm getting 60.4%. So Asia covers almost 60% of the world's population. D part says Which region is likely to experience a decrease in population between 2008 and 25? We've already discussed that. That was Europe. And what is the population of this region likely to be in 2025? So that's right there in the table, 726 million. D second, by how much is the population expected to decrease by 2050? So by how much? That's the difference. And you were right in this first question, a B part, that they're asking about the difference.
Okay.
Exercise and questions. Okay, applying your skills. We have names of the places. Okay, Mumbai, Hong Kong, London, Montreal, Singapore, Sydney. This distance table shows the flying distance. Okay. So when I'm talking about this number, that means 6754 is the distance between Singapore and London. So question, find the flying distance from Hong Kong to Dubai.
3,695.
Hong Kong to Dubai, correct. And Hong Kong to London,
Hong Kong to London is 8,252.
correct. Sydney, Hong Kong to Sydney,
Is 4,586.
correct. B part says which is the longer flight, Istanbul to Montreal or Mumbai to Lagos? Okay, this Montreal is a coincidence.
Where's Mumbai on the? Oh, there it is.
That's the first one at the top.
Istanbul to Montreal.
So this was the one, and Istanbul and Montreal. Correct. That's the longer flight. C part says what is the total flying distance for a return flight from London to Sydney and back? So London to Sydney and back
So you just 10,564 plus, so times two basically.
times two. That's correct. D part says if the plane flies at an average speed of 400 miles per hour, how long will it take to fly the distance from Singapore to Hong Kong to the nearest R? Singapore to Hong Kong. Do you know the formula for time?
It's divided, right? It's like the distance divided by the time.
Basic straight line formula is distance is equals to speed into time. And when we are talking about time, we'll make that the subject of the formula. The distance is equals to time equals distance divided by speed.
Okay.
And what would it be to the nearest hour?
The time takes years. 4 hours. Would that be correct? 4 hours?
At 4 hours. E part. Why are there some blank blocks on the table? I see these
If it
blank.
doesn't go there,
Say that again.
it doesn't go there basically.
Just see what's written in the first tick. That is
Oh,
Hong
Hong
Kong.
Kong to Hong Kong. So yeah, 0. London
Mm,
to London.
Either zero or we say that's the same place. So we are not finding the distance between these two cities. Okay. Changing the theme using charts to display data. Now, these were tables. Using charts to display data worked example. The table shows pictogram. This is some collected data. The table shows how many books 5 different students have finished reading in the past year. Amina read 12 books, then Becky, the below, Saul, Lineal, and number of books are given. And how are they representing it? Did it go? It's loading. Let me open that again. Load it. Okay. So pictogram, we may have our own key. Whoever completed this, he said that one picture is equals to 2 books. So if I see 1, 2, 3, 4, 5, 6, that is actually 12 people or 12 books. I'm in a read 12 books. So that's 12. I'll be drawing 7 books, 6 books. And for 14, I'll be drawing 7, 8, I'll be drawing 4, 16, I'll be drawing 8. And for 15, that's an odd number. So we have 7.5, 7 complete books, and 1 half is there. So this is a pictogram. Let's go for some example question. Let's say question number 3. The pictogram shows the number of fish caught by 5 fishing boat during one fishing trip. Number of fish caught per boat. So one of the picture shows 70 fish. Which boat caught the most fish?
Real deal.
Real deal. Which boat caught the least fish?
Fishtails.
Fishtails. How many fish did each boat catch? So starting with the first one,
210.
210, correct?
1, 2, 3, 4, 5, 6. 120. 420.
That is 1, 2, 3, 4, 5, 6. So I'm going to multiply 6 into 7.
420. Yeah. I said that.
Okay, sorry. I heard 2020.
Okay.
It's third one,
140.
140. Real deal,
490.
490. Right move.
Um, half of 70 basically afterwards, right?
Yes.
That's
Yes.
a half. Okay. That's 35. So it'd be 140 plus 35. 175.
175. Okay. So we discussed pictograms. Now these are bar charts. Bar charts could be represented horizontally or vertically. As we discussed, one of the examples like cricket, badminton, table tennis, and I'm writing nothing on y-axis, but you would clearly know which sport is like the most. So we could have like vertical bars and horizontal bars. Now this is one of the data which represents March, February, January, December months and number of days of rain. So it rained the most in February. And number of books taken out of the library. So number of books and per month data is there. It could be represented vertically, horizontally. That's a personal choice. It makes no difference in the presentation. Now, there are different methods of drawing bar charts, but all the bar charts should have a title that tells what data is being displayed. That is pretty obvious. and a number scale or axis so that you can work out how many are there in each class. Now, if I just go back and I can write that this is 1, this is 2, this is 4. Still, there's a doubt. What is this 1, 2, 3, 4? Because there's nothing labeled on y-axis. And if I say on y-axis 1 equals 1000, so I would know there are 4000 badminton players, there are 2000 cricket players, and there are 1000 tennis players. So title should be there, axis should be labeled, a scale on axis that lists the categories displayed, bars that are equally wide and equally spaced. Now, what does this mean? If
They
I
have
just,
in width and length. I mean, not length, but width, basically. So the bar looks organized.
yeah, but if I have it like this will give a misinterpretation that maybe option A and B, maybe B are double in number. So the width should be same. Worked example. The frequency table shows the number of people who were treated for road accidents, injuries in casualty department of a large hospital in the first 6 months of the year. Draw a bar chart to represent the data. Note that bar chart frequency axis should start from 0. So they're starting from 0. And why so? Just look at this. If I just make these like this is 60, and then this is 70, and this is 80. And if I don't start them from 0, I'm drawing it on the same graph so we can have a better comparison. If I don't start this blue one from 0 and I started from 50, so this would end at 60. This is 70. I'm making this a distance of 10. So 60, 50, another distance of 10 is 70. Now, just by looking at these two bars, one would think the second bar is actually double of the first. But in reality, it was not. For example, first student got 60 marks, second student got 70 marks. But the second graph is giving an impression that these are double of the first one. So they should always start from 0. Now, patients admitted as a result of road accidents, we have months and then number of patients. January, February, March, April, May, June, and there's ups and downs and heights are mentioned. So categories are labeled, bars are of equal width, they're starting from 0, and x-axis are also labeled. Number of patients clearly. If suppose these were 50,000, we would have written number of patients times 1000. And we would understand we have to multiply every number with 1000. Now, what are compound bars? Before going into detail, picture explains itself.
Two bar charts, just one bar chart displaying two information.
Two informations and a comparison. So, like for example, okay, first let's read this, then I'll compare it with another example. A compound bar chart displays two or more set of data on the same set of axes to make it easy to compare the data. This chart compares the growth rates of children born to mothers with different education level. So no education, if there were mothers with no education were 57, so children born to them were 22. So what's actually happening? May I say number of uneducated people are decreasing. That means more people are actually getting education. Secondly, may I say generally, as the people are getting educated, the birth rate is also decreasing.
Mm-hmm.
A general trend. So we can add two informations. For example, I say that in 2010, 2011, and 2012. Let's say one of the electronic store, they summarized their sales in 2010. This was like the television. And let me complete this and change the color so it's better to understand. Okay. Blue one represents the TV and red represents the LCD. So what do you think is happening from 2010 to 2011 to 2012?
The
Every
L
passing is happening.
the LCD is increasing while the TV is decreasing.
Yes. And if we like have a class of general science or we are attempting an ACT exam, if we are giving reasoning, we may consider that why is actually the sale of TV decreasing? It's not about the cost. Have you seen televisions around you,
Yes.
like the televisions or the LCDs, the slim ones?
Yeah.
So basically, those are LCDs, and it's not about the price. It is first thing about the quality. Second thing, they offer better eye protection. Televisions actually used electronic guns, electron guns. So that gives more light exposed to your eyes. Okay, this is an exercise now applying your skills. Draw a bar chart to show each of these set of data, one and two both. Favorite takeaway food, burger, noodle, fried chicken, hot chips, others, and number of people. On the other side, African countries with the highest. Okay, that's A and that's B. Draw a bar chart to show each of the set of data. So I would prefer a vertical bar chart for this. I'm just using these initials. That's a B, N, F, H, and O. And 40, 30, 84, 20, 29. And it would be, please bear this with me. It would be very easy if I had a marked graph paper or like the boxes. So I'm just labeling this as 10, 20, 30, 40, 50, 60, 70, 80. Now first are 40, 1, 2, 3, 4. So I'm making that height till 40. And in exam, we usually shade these. Why do we do so? We use lead pencils on graph papers.
Mhm.
And if those graph papers are like light blue in color, it is easy for the examiner to read. But if those lines are in red, lead pencil are not that visible on red squares. So we just shade them just like this. I've shaded these. Let me allow me to show one more comparison if I just add few more bars because all three are in different color. So they are pretty much visible already. But if I would draw them all in blue and now compare if I shade them, so it gives a better visibility to the reader and to the examiner who's checking your exam. Okay, so burgers that are at 40 and then noodles at 30. We make sure that the width is same and this is 10, 20, 30, 40 and so on. Fried chicken is 84, 10, 20, 30, 40, 50, 60, 70, 80. That's 80. So a little higher than that is 84. Then at 20 and others are at 29, a little before 30. Any confusion in understanding this? Here is a set of raw data showing the average summer temperatures in degrees Celsius for 20 cities in the Middle East during 1 year. A part says copy and complete the group frequency table to organize the data. I was about to ask what type of table is this, but it already stated grouped frequency. How can we tell that it is grouped frequency table?
Because it's divided into different categories, basically.
We have different categories, different sections, and we call them class boundaries or class limits. When we are talking about 32 to 34, these are boundaries. And when we talk about like 31.5 to 34.5, these are limits. We will go into detail in next few chapters. This is when we don't have gap between them. For example, you see 34, if I have a temperature 34.2, where will I place that? 34.2.
35 to
Getting
30.
the point? No, 34.2 is actually less than 35 and more than 34. So there's a gap. There's a gap. So we call them class boundaries. And when there's no gap, we call them class limits. And let me show you. Why are we actually getting these bars? If I need to draw, this is from 32 to 34. Then it is from 35 to 37. Then it is from 38 to 40. So these are known as bar chart. And when we have no gaps in between, they are known as histogram.
Mm.
Data is not changing. It is just the difference of gaps. Okay, copy and complete the grouped frequency table to organize the data. So now I'll have to look closely if I don't mess it. 32, 33, 34. I'm counting these. 1, 2, 3, 4, 4. 4 in the first one, and then 35, 36, and 37. 1, 2, 3, 4, 5. Now 38, 39, and 40. 1, 2, 3, 4, 5, 6, 6. Now 41, 42, and 43. 1, 2, 3, 4, 5. A quick add up to see if no values is missed. 4 plus 5 plus 6 plus 5 gives me 20. And these were 20 cities. Now draw a horizontal bar chart to represent the data. Horizontal bar chart. So I am going to write my categories on y-axis. Okay. So for horizontal bar chart, this is 32 to 34, 32 to 34. Then that is 35 to 37. Then we have 38 to 40. And the last one is 41 to 43. And on the x-axis, this is 4, 5, 6, 5 something. So we always start with 0. This is 1, 2, 3, 4, 5, and 6. Trying maximum to get the same distance, same differences. Now 32 to 34 is 4. So just above 4, this is my horizontal chart. And then from 35 to 37 is 5. So above 5 is this point, 35 to 37. Then we have 6 from 38 to 40, 38 to 40, and that's 6. And the last one, 5 again, 41 to 43. That's 5. And it should appear at this point. If I only disappear this gap between them, we will call it histogram. Currently, it is bar. Now, already all these colors are different. I'm going to shade them. Just see how the visibility changes. It is not the lead pencil on the printed graph page. I'm going to shade them. Can you have a look at the screen while I shade? You see? Now eyes are, I think, getting stable when we do that, and we can clearly see them. Keep that in mind, whatever board you appear for. Always give the checker ease to check. That makes a difference. He's also human. Okay. Draw horizontal chart. Done. Question number 3 says the tourism organization of a Caribbean island records how many tourists visit from the region and how many tourists visit from international destinations. Here is the data for first 6 months of this year. Draw a compound bar chart to display this data. Now, what would you prefer on x-axis and what on y-axis?
Which bar chart would I prefer for this information? Probably
It is a compulsion to draw the bar chart, but where would we place our x-axis and y-axis? What should be on the x-axis?
on the x-axis should be the regional visitors and the international visitors.
Okay. And when we draw Jan to June on y-axis, okay, this is January, February, March, April, May, and June. So this will give me a horizontal bar chart. A vertical bar chart. Regional visitors and international visitors. So in January, we have 12,000 regional visitors and 40,000 international visitors. Let me please do it the other way around. That would be very easy to write in this working space. January, February, March, April, May, and June. I'm writing the numbers on y-axis. And I can see the smallest value is 2000 and the highest value is 40,000 in this case. So we can label our axis. Let it be like 5, 10, 15, 20, 25, 30, 35, and 40. 5,000, 10,000, 20, 30, and 40,000. Now I'm going with the regional visitors first only. So that is, there are 12,000 regional visitors in January. So this is 10, that is 15. And somewhere here in January, these are the regional visitors. In February, we have 10,000. In March, we have 19, slightly before 20. In April, we have 16, just above the 15,000 mark. In May, we have 21,000, slightly above the 28,000 mark. In June, we have 2,000. I'm changing color for the other one. Let me say we chose red for regional visitors and we chose green for international visitors. Now that's 40. Then we have 39,000. Then we have 15,000. Then we have 12,000. May we have 19,000. In June we have 25,000. Any confusion?
No.
Okay. So we discussed uh, two-way graphs. We discussed two-way tables. We discussed compound bar charts. And now we are going to discuss pie charts. A pie chart, a pie chart is a circular chart which uses slices or sectors. Do you remember the difference between sector and segment?
Yes. Sector was going through like the middle basically, or touching the middle, and the segment does not go through the middle point, midpoint basically.
That's right. Or we can say sector segment is made by a chord
Mm-hmm.
and sector is made by radius. Okay. So they are represented as sectors of circles to show the data. The circle in a pie chart represents the whole set of data. For example, if you surveyed favorite sports played by anyone, or as we discussed earlier, favorite flavor of ice cream, what toothpaste do they use, and other options. Now, if they are displayed, how lion spends a typical day, and we are talking about sleeping, socializing, grooming, attacking, eating, and I'm surprised there's least eating, and most of the time he's sleeping. So if I just look at this table, this color scheme and this size gives me a very good impression that he spends most of the time sleeping, even if I don't look at these values that what is the exact value. And if this diagram would have been for the flavors of ice cream, I would exactly know where I need to invest. How elephants spend a typical day eating, sleeping, not forgetting, and so on. Okay, now this is how pandas spend their typical day being adorable all the time. Now, what's this 1%? How jellyfish spends a typical day? Running and perfectly good day at beach, ruining a perfectly good day. So they're not ruining a perfectly good day. That's 1%. And most of the time they're just floating. If I had to represent this data as bar, this would be 90%, that would be 9%, and that would be 1% only. Both of these give the exact same impression. That is just a personal choice how you want to represent this data. Now, for example, you see these sectors in case of lions. We have five different sectors, one, two, three, four, five. And in case of elephant, we have only three. So 5 and 3. If I say we have 17 different sectors, would you prefer this?
Which one?
Would you prefer drawing a pie chart if you have 17 different options?
No, I don't think so.
That's right. So it is a choice that very much depends, firstly, personal choice. Secondly, that depends what the type of data is, how much extensive the data is. As I just mentioned that 17 different sectors, So it would be very hard to label them and show them. That would be better if we like draw a graph or we draw bar charts for that. Okay, work the examples and how actually we find this angle. No data is given here, so let's try this. This is the number, and we know that a circle is 360 degrees. So if I have to divide it, this is 7 out of 24. So 7 out of 24 of 360 is 105 degrees. So school activity at school will be represented by 105 degrees in the pie chart, and so on. This is 120. I'm copying these values from the worked example, okay?
Mhm.
And do you understand why are we using this formula? 7 out of total times 360. Do you understand this? If no,
I
I can
understand the formula.
okay. Some students actually do it by unitary method. They used to write this for their better understanding. They say that 7 people would represent x degrees, and if 24 people are representing 360.
Hmm.
24 is total, 360 is total, so 7 would represent x. And when we cross multiply, we exactly get this back. That is 7 into 360, on the other side x into 24, then making x the subject, 24 comes back. So 7 by 24 times 360. And there's no compulsion in Cambridge how you approach this. You can directly write this as well if you understand it. So once we find the angles, we can draw the pie chart. Now, we are having the angles 105, 120, 22.5, 45, 37.5, and 30 degrees. And this is how it looks like. Now again, in this case, if in this case, one of the value was very small, then one of the sector would be very slim, right?
Mhm.
And if people are sitting in the room and you're presenting this on a projector, they won't be able to see it because that's very slim. In that case, we may prefer
Pictogram.
pictogram because they are very clear to read. Another worked example, and this is the exercise question. Let's do this. Select any question out of these, one or two.
One.
Okay. The table shows the results of the survey carried out on a university campus to about find out about the use of online support service among students. Draw a pie chart to illustrate this data. Okay, most of the time you'll be given a total in the question statement. In this case, it is not. So I'm just adding all these three. This
400.
is very good. That's 400. So I'm always having a denominator of 400. So it is 180 by 400 into 360. First angle, 180 by 400 times 360. You have a very good habit when you don't use a calculator. Keep that up. You will be allowed a calculator in all of your exams in IGCSE, but mental math, as far as you're comfortable, keep doing it that way. This is 162 degrees, and then for 120 by 400 times 360. That's 108. So we have 162, we have 108, and we have 90 degrees. Now we have to represent that accurately. We'll use a compass, draw a circle. We already have that center point marked. So I'm representing this 90 degrees first, that I feel that it is the easiest. So I draw a vertical line and I draw a horizontal line. Currently, what I'm doing, I'm just estimating. During exam or on paper, it has to be accurate. We will use our protector. And I'll write 100 here. Or just ignore that. I'll be writing use online support presently. Use online support in past. Never used. Okay. So let me say present and past and never used. Okay. Now we have 108 or 162. So we can draw any of these two, and third would automatically be listed. So I'll place my protector and I'll see it from 0 to 108. If it ends right at this point, I'm going to remove the protector and draw this line. And this would look like as it displays. And so 108 is past and never used. So this is our pie chart. If this would have been a bar, it would be never used in past and present. So never used is 180. This is 120 and present is 90. It would look like this. So both are giving the exact correct impression, and that they never used was the maximum chunk of it.
So for the bar graph, we also use the angles.
We can use anything, but it is preferred to use the numbers
Yeah, okay.
because actually we don't have to process the data for that.
Okay.
So that's 180, that's 120, and this is 100. For pie chart only, we need to calculate these angles. Okay, let's see this colorful question. The nationalities of students in an international school is shown on the pie chart. Brazilian, French, Indian, American, and Chinese. What fraction of the student are Chinese?
Looks like a quarter.
Looks like a quarter. That's right. It is 90 degree, but in reality, how would we do that? We will use our protector. For example, this is 80. For example, so we'll do 80 by 360 and simplify this, and that would be our answer. So what fraction? It is 1 by 4 because that's 90. So 90 by 360 is 1 and 4. 1 by 4 in this case. B part says what percentage of students are Indians? Now Indians is in this purple color. Just make a guess. What do you think these are?
1/8 maybe? Or one
In
second
degrees. Can you make that guess? In degrees?
in degrees.
I think that's between 25 and 30 somewhere. For the ease, can we take 30 degrees?
Mm-hmm.
Okay. For example, this is 30 degrees. So what percentage of students are Indians? This is 30 degrees out of 360 degrees because no total is given. No one said that these are like 1 lakh students, 100,000 students. So 330 divided by 360 times 100 to find the percentage. 0 goes with this, 3 1 times, 3 12 times, 100 by 12 is approximately equal to 8.3%. Question C part says, write the ratio of Brazilian students to ratio of student as a decimal, total students as a decimal. So, okay, Brazilian are in yellow. And what does that look like?
90 degrees as well.
That looks like 90 degrees. So 90 ratio, what should I write in the second half?
90 to 360.
90 to 360. And my answer is
1 to 4th.
1 to 4. If there are 900 students at the school, how many of them are 1, 2, 3, 4? Okay, he's asking about 4 of these. If we have 900 and we considered Chinese at 90 degree, so this would be 90 by 360 of the total 900.
Hmm. So that is
This habit, when you are not using the calculator, would help you a lot in SATs. You have two sections. One is calculator, other is without that.
225.
225, that's correct. And all others would be done in the same manner. Line graph, probably the last type of this chapter. Okay. Now what is a line graph? We do have all the data and we connect those dots with pencil, using pencil and a ruler. And it depends. Examiner may tell you that draw a smooth graph or draw straight lines. So line graph is some data that you collected changes. For example, let me just ignore this. And if I just write it like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, and I say that we are recording the temperature for 7 different days, and we see that the temperature was 20, then it was 25, then it was 22, then it was 35, then it went to 39, then it came back to 20, and again back up, and so on. So this is what we get, and we can tell the fluctuations. Along with that, if someone says that this is a major drop in temperature, so what would have happened? So the reason could be winds, rain, cloud shelter, so any possible reason with given extra data. Okay, some data you collect changes with time. Example are the average temperature each month. They keep on changing. Of the year, the number of cars each are in a supermarket car park. That too keeps on changing. Like the maximum density when you call that a rush hour,
Mhm.
or the amount of money in your bank account each week. Definitely that keeps on changing. Expenses and then earnings. So the following line graph shows how the depth of water in a garden pond varies over a year. The graph shows the water level in the lowest between June and August.
The
Okay,
hottest
if it was, sorry,
hottest months
hottest months,
for evaporation probably.
evaporation. If I just draw this graph and I say, mm, let me just sketch that first. It drops down and then it shoots up. Then it drops at a different rate. Then it shoots up and drops like this and so on. If I say that this is a salary graph for someone,
Mhm.
can you make a guess that at what point A, B, C, D, E, F is he receiving the salary?
The money basically.
The money raises, yes.
Or
So
B to
at what
C
points?
and B to C and D to E.
B to C. B to C. May I say C? that he just received the salary
Mhm.
and he and A. And what's happening between A to B?
It's dropping, so he's probably using the money.
Is using the money. So may I say this is the first of the month and that is the 30th.
Mhm.
And then again the next month, the first and 30th. So this is fluctuation. Choosing the most appropriate chart. Now this is the comparison. Let's go through this. Advantages, disadvantages. Before we read in detail, do you remember what pictogram was?
Yes.
Bar chart,
Mhm.
pie chart, line graph, which we just did. And okay, now pictogram, I'm skipping this detail because you remember what it is, and we are reading the advantages and disadvantages. Pictogram is attractive and appealing, can be tailored to subject, easy to understand, size of categories can be easily compared. Any doubt in any of this, any objection?
No.
Disadvantage. Symbols have to be broken up to represent in between values. If I'm talking about the books, half book is easy to make. If I am drawing ball, half ball is easy to make. But you remember about the fish? So half fish is to be made.
Mhm.
So symbols have to be broken up to represent in between values. And that is a coincidence that what we did was halfway between. Sometimes it is 25% of that. In case of ball or wall clock, this is complete. This is half. That's a quarter. That's easy to make. But if I'm representing like sports goods or something, so what would I make 1/4 of a racket? The handle side or the shooting side? So that's a disadvantage and can be misleading. Now, bar charts. Clear to look at, easy to compare. Which one is the most, which one is the least. Scales are given so you can work out values. Disadvantage. Chart categories can be recorded to emphasize certain effects, useful only with clear set of numerical data. As compared to the pictogram, even if we don't like have the exact data, which we just did, Chinese, Indian,
Mhm.
we just had the colors and there was no number, but we can make a fair comparison. The pie charts looks nice, is easy to understand, easy to compare categories, no scale needed, can show percentage of total of each category. Like as we did the quarter for Chinese, we can say that's a quarter, we can say that's 90 degree, we can say that's 25%. Our mind just comprehends it without working, without doing mathematical calculations. And what is the disadvantage? No exact numerical data. We just saw that. Other categories can be a problem. Acha, okay, hard to compare two set of data. Obviously, all the pie charts we're doing are having one data. So like two table charts, we cannot draw a pie chart for them. Total is unknown unless specified. If I tell you that we are working out of 7 days, how many days it rain and how many days are dry. So if I say raining and drying, when I mention weekly, only then you know what the total is. If I say monthly, if I say yearly, but this is the data. It could be understood that most of the days are dry, less are rainy, and the total is unknown unless specified. Line graph shows more details of information. Let me go back to that. If I say how much money did he add on the 7th of the month, we can look at the graph and predict that value. If I say what was the depth of the water in between February and March, we can go to the graph and predict that value. If I say what was it like these are 5 small boxes. So one box would represent 6 days, 6 days after May. So there is a lot of data and a lot of detail in line graph. Actual data is there. So shows more details of information than other graphs, shows pattern and trends as well. In between information can be read, which we just discussed. It is known as interpolation. And when you actually need to read outside the box, for example, you have this graph and it looks like this. It starts at 1, it ends at 7. And what if I ask you to find the value at 8? So you can always extrapolate it and tell that this is the expected value. So line graphs gives you that leverage. Has many different formats, can be used in many different ways. For example, conversion graphs, curved lines. One of the type is right in front of you, that is linear and increasing. One of the type is this, keeps on decreasing, then increasing. Was that understandable? If we know that we are talking about celery, and this is the depth of water, it shows the trends as well, decreasing, increasing, and the exact value of the depth and the time of the year. So that gives you the maximum details. Okay. Disadvantages. Useful only with numerical data. I cannot draw line graph for this. Scales can be manipulated to make data look more impressive. Why is that a disadvantage?
Well, it can be false. It cannot be. It doesn't show honesty. It's dishonest.
Mm, it should be the case. Like, why would Balam present false data?
Mhm.
Uh,
Well,
maybe this is the disadvantage because there is a room for improvement. It could be improved.
oh, on the line graph, the example line graph. Uh,
Okay. This one,
yeah, between the 0 and 30, there's like a little squiggle or something. What does that mean on the
I'll
scale?
let me think of an example. Okay, before that, I'll explain. This is actually known as a jag line. Now, if you actually do not have any data, let me say we are talking about the population of people in a concert and or in a political ground, and they are like in hundreds of thousands. So if I say there was one party and in their ground there were 100,000 people, another place, let me say this is A, this is B, this is C, this is D, there were like 98,000, and then 102,000, and then 125,000, and then we had like 136,000. Now what happens if I draw this graph from 0? Where will I actually mark this 100,000? It has to be somewhere. So I can see that the lowest value is 98. What if I just start my graph from 95? So I can say this is 0 and I draw a jack line and start my graph from 95, because now I can stretch my graph. If this is 95, let me say that's 100. That is 105, and that is 110. And my values lie till 136. Okay, 10. This is 20. This is 30, and so on. Now I can vertically stretch my graph. So quickly marking them like 100, 98, 102, 125, 136. So that is a vertical stretch and I can make that comparison. But what if I draw them from 0? This is where somewhere it would be 100, and this is where somewhere it would be 130. So all my graph is lying between this, and all this region is empty. So that is why we have this jack line. And we can have that in the horizontal axis as well, or the vertical, depends what are we presenting.
Okay.
For example, I remember. Okay. Mm. You remember the example of death rate and birth rates?
Yeah.
The chart at the hospital. So if I just draw that again, and if I have to represent them as like numbers, and we are talking about thousands, so we can make a jack line here and then start from it. This is 0, and we are starting from 100,000. Or else what it would look like, again, this is 0, this is 100,000, and all the points are lying here. All this region is empty. So that is the main reason. Yeah, I'll share few questions and I'll try to like cover one question for each, like line, pie chart, bar chart, and so on. Anything you would like to ask?
No.
Thank you so much. Take care of yourself.
Hmm?
You want to
Sorry?
ask?